Okay, so in this class, let us discuss this question. Okay, you can write it down. How are first one, sodium ion, B, magnesium ion, Mg2 plus, and aluminium ion, Al3 plus formed? So understanding how these ions are formed is going to be critical in understanding the next test. Okay, that is 3D. So let us start it. So to begin with, let us keep this one noble gas or the noble element neon. Okay, neon, whose symbol is capital N small e, that means the first two letters. Okay, and we know this is a noble gas, keep it as a reference. And here for noble neon, atomic number is 10 and its mass number, write it down along with me, is 20. Okay, so to clearly understand how this sodium ion, magnesium and aluminium ions are formed, let's first understand atomic structure of a noble gas, that is neon, because it's related to how these ions are formed. Okay, so let's now draw. We have learned in the previous class also, every atom has a center nucleus here, so nucleus, middle part. So we can just draw a smaller nucleus, and then nucleus means, okay, before that you can write out. So atomic number means number of protons. So number of protons, atomic number 10 means neon has got 10 protons. And number of electron will denote by E is always equal to number of proton in any atom. So if neon has 10 proton, it will also have 10 electrons. And number of neutrons is mass number minus atomic number. So mass number is 20 minus atomic number, and that will always give you the number of neutrons. So 20 minus 10 is 10 neutrons. So atom has these three fundamental particles: protons, electrons, and neutrons. So we have found out that neon has 10 protons, 10 electrons, and 10 neutrons. So if we know the protons, electrons, and number of neutrons, we can easily draw its structure. So let us draw its structure, maybe here. So center nucleus has always protons and neutrons. In the nucleus are present the two atomic particles, protons and neutrons. So this 10 protons of neon will be in its nucleus and 10 neutrons in the nucleus, and stationary, not moving. And it has 10 electrons, and this will be revolving in the circular orbits. That means they are not stationary, they are moving in orbits. And the number of electrons in first shell according to Bohr-Bury rule is 2. The second one is maximum 8. So 1, 2, 3, 4, 5, 6, 7, and 8. So 8 plus 2 in first shell, 10. So that is the electrons, 10 electrons. 2 in the first shell, 8. So perfect, right? So 10. So this is the structure of neon atom. So it has 10 protons, means 10 positive charge, and it has 10 electrons, means 10 negative charge, because each electron carry one negative charge, one unit negative charge, and each proton carry one positive charge. So since number of protons and electrons are equal in any atom, like in this case neon atom, so they will have equal number of protons and electrons, and each proton has positive and electrons has negative. And since they are exactly equal but opposite shape, plus minus, it will be 0. Plus 10 minus 10 is 0. So atom has no charge, therefore no atom has charge, because number of protons and electrons are equal. So keep that in your mind, and then we will start with the how sodium ion is formed. First one. So here's sodium ion. Write it down, Na plus. Write all these things up here. Okay, follow me. Now to understand how sodium ion is formed, we have to take the structure of sodium atom. So here, you know that I'll do directly. Okay, sodium atom has, you can draw along with me, here 11 protons. Okay, it has got atomic number of sodium is 11, so it has 11 protons. And we know that protons and electrons are always equal in number. So sodium atom has 11 protons, means it will have 11 electrons. So 2 in the first shell maximum. 1, 2, 3, 4, 5, 6, 7, 8 can go maximum in the second shell according to Bohr-Bury rule. First shell is always 2n square formula, 2 electrons. Second shell, by applying 2n square formula, we learned this in previous class. A third shell maximum by applying Bohr-Bury rule, 2n square, 18 and so on. We know that. So 2 in the first orbit, 8 in the second orbit. So that's done. So but sodium has got 11 electrons, just like it has 11 protons. So 2 plus 8, 10. One more is there that cannot go in the second shell. We have to draw the third orbit. So the third orbit is having 1. So 2 plus 8 electrons, 10 plus 1, 11. Sodium has like that. And just for information, sodium has got 12 neutrons. Okay, just write it, draw it. So what is this? This is sodium atom. Please write it down. Sodium atom structure. So what happens is this: in order to become like the noble gas neon, the electronic configuration of this neon is here. So you would agree with me. Neon has, you keep some space here and write atomic number. Okay. So after drawing the structure, you see here 2 in the first shell. So the electronic configuration of neon is 2 electrons in first shell. Electronic configuration means how the electrons are arranged in an atom. Okay. And here 2 plus 8. So 2, 8, 10. So like this, its configuration is like this. So this is perfect arrangement. That's why 2 and 8 exactly. That's why not 7, 6 also, but exactly like 2 and 8 perfect. That's why it's called a noble gas or noble element. So sodium is not perfect. 2 plus 8. So sodium atom configuration is here. See, 2 electrons in first shell, 8 in second shell, and then what happens? Okay, let me just draw it here. Sodium atom. So here sodium atom has 2 in the first shell, as you can see, and plus here 8 electrons. And it's not perfect because it has 11 electrons, because there are 11 protons, 11 electrons, and one has to be gone to the third, has to go to the third orbit. That's why 2, 8, 1. And it's not perfect because in the third, the perfect is 18, right? So since it's not perfect, it is always in that state. Sodium atom is not perfect like neon. It is always in that tendency to acquire the electronic configuration of neon, like 2, 8. So in order to become like neon, it has to lose this 1 electron. So what will it do? It will lose this 1 electron. Means it will come out. Then the structure will become, you know that if this electron has been removed, 1, this one is removed, then it becomes 2, 8. 2 plus 8, exactly like neon. So since it's not perfect, sodium atom is always in that tendency at any given opportunity, slight opportunity also, it will try to lose this 1 electron. So it loses this 1 electron, then the structure, just look at this, this has gone, stripped off, just like removing a jacket. Okay, removed. Then the rest of the structure is, this nucleus is not touched in the process. 11 protons, 12 neutrons, and here this also not touched. 2 electrons, as you can see, not touched. Here also not touched, so 8 are still there. 1, 2, 3, 4, 5, 6, 7, 8. So this has become 2, 8 because 1 is stripped. So exactly it has become like 2, 8 electronic configuration of neon. So it has managed to do that by losing 1 electron. That's why its valency is 1. So this one is what? This one is, you see here, how many protons are here? There are 11 protons, and we know each proton has each 1 positive charge, so protons. And now count the electrons, 1, 2, and here 8. 1, 2, 3, 4, 5, 6, 7, 8. So 8 plus 2 is only 10 electrons. Each electron has negative charge. They are unequal now, unlike in atom where there are 11 protons here in nucleus and 11 electrons, including this one. So 11 protons means 11 positive charge, 11 electrons, 11 negative charge, 11 positive, 11 negative, exactly cancel each other. So there is no charge, zero charge. But here there will be charge, because see here, proton is still 11, not touched, but one electron removed, so it will become less. 11 has decreased to 10 electrons, so 11 minus 10 is 1. Bigger number is 11 having plus. So a plus sign will appear here at the top of this structure, which is same as the electronic configuration of neon 2,8 here. So what is this? This is nothing but sodium ion, the one having the charge. Okay, that's why a plus charge. Since one electron is lost, only one positive charge extra is coming out, plus. So how would you write that in equation form? Sodium atom we know it's written in the form of, okay, so here, excuse me, here sodium atom we know is symbol is N capital small a. So sodium atom, this one having 2, 8, 1, just like this. It will lose this one electron. Then we get here, this structure is Na1 plus, because one electron is lost, so one positive charge dominating, and this one is having the configuration 2, 8, exactly like neon. And so sodium ion is, okay, excuse me, sodium ion is formed. Okay, sodium ion is formed. So sodium ion, so that is how sodium ion is formed. When sodium atom lose one electron in its tendency to acquire the electronic configuration of neon 2,8, like this, 2,8,1, the atom lose one electron to get 2 electron and 8 in the second shell, just like neon. One electron is lost to acquire that configuration of neon by sodium atom, and in the process sodium ion is formed. So that is how sodium ion is formed. Let us go to the next one. Okay, the next one is, keeping this neon again, B will go to B. So B is, as you can clearly see, B is magnesium ion. Let us see how magnesium ion. Understanding how these ions, some of these ions are formed, will help us to do the test 3D clearly, okay, by understanding. So magnesium. Now let me draw the structure of magnesium atom. So here magnesium atom has got 12 protons, okay, and then it has got how many neutrons? Directly I'm doing it, 12 neutrons. So mass number is 24. So it has 12 protons, means it will have 12 electrons, because in any atom the number of protons is always equal to the number of electrons. So they have no charge. 12 protons, 12 positive charge, 12 electrons means 12 negative charge. So plus 12 minus 12 cancel means 0 charge. There's no charge. Atom is therefore neutral, no charge. Neutral means no charge. 12 proton means 12 electrons. So in the first shell, maximum 2 can go according to Bohr-Bury rule. Second shell, 1, 2, 3, 4, 5, 6, 7, and 8 can go. Right, we know that. And then 12 protons means 2 plus 8, 10. So that 2 proton cannot be put in second shell, because according to Bohr-Bury, second shell maximum is 8. So those 2 extra will go to the third orbit, and the third orbit has got 2. So 2 plus 8 in the second orbit, 10 plus third orbit 2. So 12 electrons, 12 protons. This is the structure of magnesium atom. So its configuration is, as you can see, 2 in first shell, electron arrangement, 2 in the first orbit, 8 in second orbit, and 2 in the third orbit. So in order to become like neon 2,8, what it will do? Now before that, let me just mention this once more. So there are 2 electrons in the third orbit, which is the outermost orbit. That electron in the outermost orbit are called valence electrons. So in the previous one, sodium had only 1 in the outermost orbit, so it has only 1 valence electrons. But magnesium has 2 valence electrons. So what will happen? It will lose these 2. So these 2 electrons, 1, 2. Why will it lose these 2 electrons? Because if it loses these 2 electrons, it will have 2 electrons in first orbit and 8 in second orbit. 2 plus 8, 10. 2 in first orbit and 8 in second orbit, just like neon. So just like sodium has a tendency to become like neon, every atom also has the tendency to become one of like the has a tendency to acquire the electronic arrangement of one of the noble gases, in this case neon. So 2 electrons lost, then the structure is common sense. These 2 removed, then the rest you draw same, because the rest is untouched. So here 12 protons and 12 neutrons, and here 2 not touched. First orbit, second orbit, 1, 2, 3, 4, 5, 6, 7, 8 not touched, and third orbit removed. So if you remove these 2, then the structure is this one, and these 2 here, these 8 electrons in the second orbit. So this is the structure. So in such a case, we have now 12 protons, which is not touched, which is positive, and only 10 electrons, 2 plus 8, 10. So 10 electrons means 10 negative charge. So 12 minus 10 is 2, and bigger sign is plus, so plus 2 charge is coming. So 2 plus charge will come here, and this is nothing but magnesium ion, and its configuration is 2, 8, exactly like 2 electrons and second orbit 8, just like neon. So in other words, in its tendency to acquire the electronic arrangement of neon, which is the noble gas, it has to lose these 2, then become 2, 8 electron arrangement like neon. So it will lose the 2 electron and form magnesium ion. So that's how magnesium ion is formed. So this is the structural form. In the symbolic form, we write magnesium atom symbol is Mg and configuration is 2, 8, 2, just like this here, 2, 8, 2, 2 electrons, 8 electrons, 2 in the third. So, and it will lose these 2 valence electrons is lost, and then we got here Mg 2 plus, because 2 is lost, therefore 2 plus is coming out, and this is called your magnesium ion, and the configuration is 2, 8, just like this. So that's how magnesium ion is formed. One more is the aluminium ion. So let us go to C. So here in the C, the third one, C, aluminium ion. How it is formed? Al3 plus. Okay. For that, let us draw the structure of aluminium atom. It has got 13 protons. Okay, and then aluminium has got 14 neutrons. So let me just expand a little bit. 14 neutrons. So it has 13 protons, means it will have 13 electrons, because every atom has equal number of protons and neutrons. That means if there are 13 protons, there will also be 13 electrons. So 2 in the first shell according to Borbie rule. 1, 2, 3, 4, 5, 6, 7, 8 maximum in the second shell. So 2 plus 8, 10. So the 13 electrons are there, means the 3 will go in the third. So outermost orbit has 3 electrons. So it has valence electrons, because as I said, valence electrons are those electrons that are in the outermost shell or orbit of any atom. So in its atom, so its electronic configuration is first shell 2, second shell 8, third shell 3 now, and so this is magnesium atom structure. Magnesium atom. So magnesium atom, in its tendency to acquire this configuration 2, 8, and 2, 8, it will lose these 3 electrons. So this 3 will come out. These 3 electrons will come out, lost. Then the structure will become, nucleus is not touched, so I can just write 13 protons, 14 neutrons, not touched. The rest also not touched. First orbit is not touched. Previous 2, like previous 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So this 3 lost. So that is now the structure. And in this such a case, it has now 13 protons positive, as you can see, but here 2 and 8 electrons, so only 10 left. So on subtraction, 13 minus 10 is 3, and bigger sign plus, so 3 positive charge will appear on this structure, which is no longer an atom. So this is your magnesium ion. The one having, sorry, not magnesium, aluminium. I made a mistake here. This is aluminium, okay, sorry. Aluminium. So this is your aluminium ion having 3 plus. Configuration is here. First shell 1, 2, second shell 1, 2, 3, 4, 5, 6, 7, 8, comma 8, just like neon. So in the desire for aluminium atom to become like neon 2, 8, it loses 3 electrons and forms the aluminium ions. So that's how the aluminium ion is formed. So in the symbolic form, our equation will look like this. Aluminium symbol is Al, having 2, 8, and 3. 2 electrons in first shell, 8 in second orbit, 3 electrons in third orbit. So it will lose these 3 electrons and then acquire this structure 2, 8. So lost 3 electrons means 3 positive charge will dominate 3 plus, just like this. And so that is how aluminium ion is formed. So this Al3 plus is aluminium ion. I hope you got this. So in summary, in the end, in its attempt or tendency to form, to get the electronic arrangement of neon 2, 8, sodium ion loses 1 electron, so become Na plus. Magnesium ion loses 2 electrons, so become Mg2 plus. Aluminium atom loses 3 electrons, so it becomes L. Okay, let me summarize once more. In its tendency to acquire the electronic configuration of noble gas neon 2 having electron arrangement 2, 8, sodium atom lose 1 electron to become Na1 plus. Magnesium atom loses 2 electrons to become Mg2 plus magnesium ion, and aluminium atom loses 3 electrons to become Al3 plus, which is aluminium ion. So that's how sodium ion, magnesium ion, and aluminium ions are formed. Okay, so this, keep that in mind. We'll continue in the next class. Okay.